Hi class. Okay, so we're going to be going over the review test. So if we look at number 1, it says draw and label line segment FG. So it doesn't matter which direction that you drew it, but you got to remember that line segment has 2 endpoints. And this says F and G are our endpoints. So F and G. Okay, the second question is use a protractor to measure the angle. So we want to make sure and line our vertex right here up at the center, this little dot right here in the center of the protractor. So if we line that up and we make sure that this line, the bottom ray is lined parallel with this line, and then we can see that it's pointing to 40 degrees. Whoops, I think I made it uneven. That one looked like, okay. We follow the line, it's pointing at 40. So 40 degrees. All right, number 3, it says choose a figure that has at least one pair of parallel lines. Mark all that apply. So we see that this has parallel lines, this has parallel lines, this doesn't have any parallel lines, and these have parallel lines here. They also have parallel lines here. So we're going to mark D, B, and A. All right. Number 4, use a figure for 4A and 4D. Select true or false. So when we look at 4A, it asks ZX and WY are parallel. So let's look at it. ZX is here and WY here. Are they parallel? No, they are not. They are actually perpendicular. SU and RT. So SU and RT. It is true, they are parallel. How about ZX and WY? Are they perpendicular? Yes, they are. They are perpendicular. They have a 90-degree angle. And then 4D, a line drawn through points R and U right here, a line drawn between points R and U is perpendicular to RT. So if there is a line drawn like this, would it be perpendicular? The answer is no, because we know that for it to be perpendicular, there has to be a 90-degree angle. All right, next page. Oops. Question number 5. We see a map here. It shows a section of Fatima's town. So part A, Fatima is walking on Oak Drive and Gabe is walking on Miller Avenue. So Oak Drive is here, right there, and Miller is right here. So here and here. It's asking, will they ever meet? The answer is no, because the lines are parallel. So the lines are parallel. Okay, which street is perpendicular to Broad Street? So first let's find Broad Street. Broad Street's right here, and we see that this street is perpendicular. The name of the street is Pine Street. And we know, because there's a little 90-degree angle thing, that indicates that it's perpendicular. So let's say Pine Street and these streets meet at a 90 degree angle. Okay, right here, number 6, we say that this angle is bigger than a 90 degree angle. It's wider, so it is an obtuse angle. All right, we have a triangle here, and it's asking for lines of symmetry. If you remember, lines of symmetry means you can fold it in a direction and it'll be a mirror image. So there's multiple lines of symmetry. One is this direction. Oops, I'm going to freehand it. There we go. One, that direction, because if we fold it over, it'll mirror that way. We also can fold it this way. Whoops, that wasn't totally straight. That should go through the top, like that. And then there's another line of symmetry right here. So there are 3 different ways you can fold it. Okay, number 8. A gear and a watch turn clockwise in 1 degree sections, a total of 300 times. Remember with a protractor that each little tick is 1, so if it goes 300, then that means it goes 300 degrees. All right, here we go. Lucy is designing a block for a quilt. She measures one of the angles. Use the numbers and the symbols on the tile to write and solve the equation to find the unknown angle measure. So we have these numbers up here. We have 110 right here. So remember that half a circle is 180 degrees. So if we know this one is 110, we'll start with 110. And we'll minus the, oh, sorry, not 110. We'll start with 180. So that's this box. We'll minus 110. Sorry, that's really sloppy. 180 minus 110 will equal question mark. So 180 minus 110 is 70. You could also say 110 plus 70 equals 180. All right, number 10. Luke is drawing a figure that has exactly 2 acute angles. For 10A to 10D, choose yes or no to tell if the figure could be the figure Luke is drawing. If we look at number 1, hold on just a second. If we look at number 1, we see that this is an obtuse angle, but we do have 2 acute angles, so that is a yes. Here we see this is not an acute angle, but these are acute angles, so this would be a yes. And we know that squares have 90 degree angles, so those are not acute, so this is no. And the last one, we see this looks kind of like a 90 degree angle, this kind of looks like a 90 degree angle. These look closer to 90 degrees or bigger. The answer is no. All right, remember the little ticks mean that each side is equal. The triangle QRS can be classified, well, it's an equilateral triangle, but if we look at the angles, we see that all 3 angles are acute. So it is an acute triangle. All right, 2 more pages. Hang in there, guys. Okay. We're going to choose 2 angles that could be put together to make 130 degrees. So how I would do this is I would look at the first number, 130, and I would minus 55, and I would get 75. So do I have one that's 75? Yep, I do. So this one and this one make a 130 degree angle. If I didn't find the right answer, I would go to the next one. What do I need to add 45 to get 130? So I would find 85. Do I have an 85 degree angle? I do not, so that one would not be it. How about 65? So that's how you try to find the answer there. All right, number 13. A sign has two pairs of parallel sides and two pairs of equal sides. What is a shape called? So we look at the shape, it is called a rectangle. All right. The circle represents all the students in a class. Each section represents the students who have chosen a certain color as their favorite. The angle measures for some sections are given. All right, what is the sum of blue, red, and green? So we see blue's 130 and red is 70, so that's 200. And then we have to add green, so that's 260 degrees. Explain how to find the angle measure for pink. Then find the measure. We know that a circle is a total of 360 degrees, and we already have the measurements for all these. We're just missing this little section, just one angle right here. So we can say, we can say 360 degrees, or 360 minus 260 equals 100 degrees. So pink is equal to 100 degrees. Okay, next problem. Draw one diagonal in the figure to form two obtuse angles. So the first thing I would do is I would look at this shape. This right here looks like an acute angle. So I wouldn't want to use this angle. I'd want to use the obtuse part. So if I want to keep that one, then that means I can cut this one in half. So I would do that. Then I have an obtuse angle here, and I have an obtuse angle there. Number 16. Does a figure have a line of symmetry? Explain. All right, so if I cut this right here, would this and this be symmetrical? No. If I cut it here, would this and this be symmetrical? No. So the answer is no. No matter where you draw the line, there isn't a line of symmetry. Or there good thing I'm using a pencil. No matter where I draw a line, the shape isn't, I'm going to say symmetrical. Okay. Last problem. Oh, no, we got a couple more. Number 17. A Ferris wheel turns 35 degrees before it pauses. It turns another 85 degrees before stopping again. What is the total measure of the angle that the Ferris wheel has turned? Hold on just a second. So we have 35 plus 85, which gives us 120 degrees. So this plus this, it's going clockwise, so it's going this direction. If this was 12, 1, 2, 3, 4, 5, 6, so it's going clockwise, we would say it's 120 degrees. And how many more times will it need to repeat that pattern to go 360? So 120, if I take 360 and divide it by 120, I can figure out how many total turns, or I can just repeat the pattern. 120 plus another 120 would make 240, and then 240 plus another 120 will give me 360. So it'll take a total of 2 more turns. So I could say 120 plus 120 plus 120 equals 360 degrees. So it's already gone 120. Well, you could also say 3 times 120 equals 360 degrees. So it would need to take 2 more turns to equal 360 degrees. Okay. So next one, last page. All right, Cross Street, West Street, and Carmichael. So here's Carmichael, here's Cross, and here's West. Now the first thing I notice is there's a right angle symbol right here, which automatically turns that into a right angle. So let me read my question. How can the triangle be classified? Mark all that apply. So I see the little right angle symbol, so I'm automatically going to mark right angle. Now when I look at it, I can look to see whether the sides are equal at all. Is this side the same as this one? No. Is this side the same as this one? Nope. So none of the sides match, which means it is also a scalene triangle. Is it an acute one? Nope, because I know acute has to have 3 acute angles. Isosceles means that 2 sides are equal, and that's not the case. Equilateral means all 3 sides would have to be the same, and that's not true. Obtuse means that one of the angles has to be obtuse, and we know that that's not the case because it's a right angle. All right, question number 19, last one. No, 2 more, sorry. A stage has 4 sides with exactly 1 pair of parallel sides. Marjorie says the shape of the stage is a quadrilateral and a rectangle. Do you agree or not? So if only one side are parallel and the other pair of sides are not, it cannot be a rectangle because we know that a rectangle has 2 pairs of parallel sides. So it is a quadrilateral, however, because we know that quad means 4 and it does have 4 sides. So I will say so the stage is a quadrilateral, but not a rectangle because it only has, it says 1 pair of parallel sides. 1 pair of parallel, sides. Okay, last question. What is the unknown angle measure in this pattern? Okay, remember that half a circle is 180 degrees. So if this is 55, then what is this? So we would say 180 degrees minus 55 is going to equal 125 degree. Good luck on your test.